Welcome to Module 3 of Introduction to Crop Cultivation in Nigeria. In this module, we are going to be focusing on soil management and fertility. Lesson 1. Understanding Nigerian soil. Types of soil in Nigeria. Nigeria is characterized by diverse soil types, including sandy soil, loamy soil, clay soil, and peaty soil, each with its unique properties, characteristics, and suitability for crop production. Major soil types in Nigeria. 1. Sandy soil, light, well-drained, and low in fertility, suitable for the cultivation of drought-tolerant crops, such as millet, sorghum, and groundnut. 2. Loamy soil, medium texture, well-drained, and moderate fertility, suitable for the cultivation of a wide range of crops, including maize, cassava, and yam. 3. Clay soil, heavy, poorly drained, and high in fertility, suitable for the cultivation of moisture-loving crops, such as rice, sugarcane, and vegetables. 4. Peaty soils, organic rich, poorly drained, and acidic, suitable for the cultivation of acid-loving crops, such as pineapples, cocoa, and oil palm. Soil properties and characteristics. Understanding soil properties and characteristics is essential for assessing soil fertility, health, and productivity, and optimizing crop production. Key properties. 1. Soil texture. Determine the soil texture, including the relative proportions of sand, silt, and clay particles, to assess soil structure, water retention, and aeration. 2. Soil structure. Assess the soil structure, including the arrangement of soil particles, aggregates, and pores, to optimize soil fertility, drainage, and root growth. 3. Soil pH and organic matter. Measure the soil pH, organic matter content, and nutrient status to evaluate soil fertility, nutrient availability, and crop performance. Soil classification and mapping. Soil classification and mapping involve categorizing and delineating the different soil types and properties in a farm or region to guide soil management and agricultural practices. 4. Soil classification system. Classify soils based on the soil profile, parent material, and horizon characteristics to identify soil types, properties, and suitability for different crops. 5. Soil taxonomy. Categorize soils based on the soil properties, texture, structure, and organic matter content to determine soil fertility, health, and productivity. 6. Soil mapping and GIS. Conduct soil mapping and digital soil mapping using GIS and remote sensing techniques to create soil maps, identify soil types and properties, and optimize soil management and agricultural practices. Lesson 2. Soil fertility management practices. Principles of soil fertility management. Soil fertility management involves optimizing soil fertility, health, and productivity by enhancing soil organic matter, nutrient cycling, and microbial activity through sustainable soil management practices. Key principles. 1. Soil organic matter and nutrient cycling. Enhance soil organic matter, nutrient cycling, and microbial activity through organic matter addition, crop residue management, and soil conservation practices to improve soil fertility and productivity. 2. Soil amendments and fertilizers. Apply appropriate soil amendments, including organic and inorganic fertilizers, lime, and gypsum, to optimize soil pH, nutrient availability, and crop performance. 3. Soil conservation and erosion control. Implement soil conservation practices, such as contour plowing, terracing, and mulching, to reduce soil erosion, improve soil structure, and enhance water retention and infiltration. Organic and inorganic soil amendments. Soil amendments play a crucial role in improving soil fertility, structure, and productivity by supplying essential nutrients, enhancing nutrient cycling, and promoting microbial activity in the soil. Key amendments. 1. Organic amendments. Apply organic amendments, including farmyard manure, compost, and green manure, to increase soil organic matter, improve soil structure, and enhance nutrient availability and uptake by crops. 2. Inorganic fertilizers. Apply inorganic fertilizers, such as nitrogen, N, phosphorus, P, and potassium, K, fertilizers, to supply essential nutrients, optimize soil fertility, and enhance crop yield and quality. 3. Lime and gypsum. Apply lime to neutralize soil acidity and improve soil pH, and gypsum to improve soil structure, enhance water infiltration, and reduce soil salinity and sidicity. Cover cropping and green manure. Cover cropping and green manure are sustainable soil management practices that involve growing cover crops and incorporating green manures to improve soil fertility, structure, and health. Key practices. 1. Cover cropping. Grow cover crops, such as legumes, grasses, and brassicas, to protect the soil from erosion, suppress weeds, and improve soil structure, fertility, and microbial activity through organic matter addition, nitrogen fixation, and nutrient cycling. 2. Green manure. Incorporate green manures, such as legume residues, grass clippings, and crop residues, into the soil to increase soil organic matter, improve soil structure, and enhance nutrient availability and uptake by crops through decomposition, mineralization, and microbial activity. 3. Crop rotation and intercropping. Implement crop rotation and intercropping with cover crops and green manures to optimize soil health, fertility, and productivity by diversifying crops, enhancing nutrient cycling, and improving soil structure and water retention. We have come to the end of Module 3, let's move on to Module 4.